Good day, viewers. So I want to consider these questions, which is 9 to the power of x plus 9 to the power of x plus 9 to the power of x. And the aim of this question is to find, we ask to find the value of x. That is the aim of this question. Now, the first step to this kind of question. Now, you will notice something. You will notice that on the left-hand side, this is the left-hand side, this is the right-hand side. In the left-hand side, we have 3 9 to the power of x terms. Again, 3 9 to the power of x terms. So we're going to factor out the common term in the left hand side, and the common term in the left hand side is 9 to the power of x. So this will be 9 to the power of x open bracket 1 1 plus 1 plus 1. This is equals to 1. You can see, because if you simplify this, if you expand this rather, you're going to get this back, because 9 to the power of x times 1 is 9 to the power of x. 9 to the power of x times 1 is 9 to the power of x. And 9 to the power of x times 1 is 9 to the power of x. It's still the same thing. So moving further, we now have 9 to the power of x, open bracket, 1 plus 1 plus 1, that is 3. And this is equals to what? 1. Now you agree with me that 9 to the power of x, open bracket 3, is the same thing as 9 to the power of x times 3 is equals to 1. It's still the same thing. Now moving further, we have to find x. So we'll try as much as possible to make x the subject of formula. So anything that is with x, we try as much as possible to erase it. Now here in the left hand side, you can see that this 3 is attached to 9 to the power of x. So what am I going to do to eliminate this 3 from the left hand side? So I'll multiply both sides, because in mathematics, whatever you do to the left hand side is what you multiply to the right hand side. So I'll multiply both sides by the reciprocal of 3. That is, I'll multiply both sides by 1 over 3. Now doing that, I have 9 to the power of x is equals to 1 over 3. Because if you multiply this by 1 over 3, because if you multiply this by 1 over 3, 3 will cancel out 3 times 1 over 3. Hence, 1 times 1, 1 over 3. That's how I arrive at this. Now here, you can consider changing this to logarithm. But I won't bring logarithm into this problem. Let's solve it this basic way. So moving on, this will be 9 to the power of x is equals to 3. This is the same thing as 3 raised to the power of minus 1. It's still the same thing. There's the law of logarithm, the law of indices that says 1 over p is still the same thing as p raised to the power of minus 1. 1 over f is still the same thing as f raised to the power of minus 1. So I'm not changing anything. All these are still the same thing. So moving further, now what did I notice here? So this 9, you can also rewrite it as 3 to the power of what? 2. But don't forget there's an x here, so you attach the x is equals to 3 to the power of minus 1. Now what do you notice? You notice that they have the same base. Hence, you equate their power. So therefore, I can conclude with the statement that says equate powers with the same base. Since they have the same base, I can equate the power. In fact, there is a law that says if I have p raised to the power of any w, where w is a positive or negative integer, is equals to p to the power of y, I can say w is equals to y. Why is this statement true? Because they have the same base. This is the base, this is the power. So that is the same strategy I'm using here. Since they have the same base, I can equate their powers. And the powers are 2x is equals to negative 1. Since we are looking for the value of x, you divide both sides by the coefficient of x. And the coefficient of x here is 2. So I have over 2 and over 2. So 2 will cancel 2 such that x is equals to negative 1 over 2. So this is the value for x. Thank you for watching. Please subscribe to my channel.